Assalamualaikum everyone. This is our virtual lecture on topic 4 probability. For your information, I will continue from where I left off from class last week. And if you look at your lecture notes, this particular virtual lecture will cover pages 41 to 45. Okay guys, a bit of recap from where we left off. We've already entered into continuous probability distributions, and if you remember correctly, I mentioned that we look at our random variables. If our random variables are continuous in nature, therefore our probability distribution will also be continuous in nature. Okay, and I think I've already mentioned to you that we will only be covering the normal probability distribution. There are other continuous probability distributions, of course, but we will only be focusing on the normal probability distribution. Okay, right, so let's recap on the characteristics of a normal distribution. As you can see, the normal distribution is symmetrical around the mean. What it means is it is bell-shaped. So when you have something that is symmetrical, you only have one peak. What that means is your mean, median, and mode are exactly identical. Okay. Besides that, you can see the curve, or the normal curve, is also asymptotic, which means the curves here do not touch the x-axis. Okay, so make sure that when you sketch it, it hangs a bit. Okay, so I've also, I think I mentioned to you that there is a family of normal distributions whereby you may have cases where the normal distributions have the same mean or average but different standard deviation. Okay, so this is how they look like. What that means is, okay, remember, standard deviation talks about dispersion. The smaller standard deviation you have, the smaller the dispersion. Smaller dispersion means both from left and right, it's basically pushing all of your data into the center. That is why, if you look here, see, for the Camden plant, it has the smallest standard deviation. Therefore, it is the narrowest. See, the red colored distribution is very narrow compared to Elmira plant, which has the bigger standard deviation. So look at the blue one. See, it's more spread out and more, it's flatter. Okay, so yeah, so this is basically the case of same or equal means but different standard deviation. We may also have the cases where our means and standard deviations are very much different, and also the cases where if you look at our distribution here, they look exactly the same shape because they have exactly the same dispersion, but they are located differently because they have different means. Okay, so this is basically what was covered in our last class last week. Back in topic 2, you learned the concept of empirical rule. Now, this empirical rule is very much related to the normal distribution. This is because we can use this rule only for a symmetrical distribution. Now, if you recall, how do we use or apply the empirical rule? First things first, you need to find the z. So the z is basically found by finding the distance, which is the difference between a particular x value from the center or from the average. Once you have the distance, you divide it with the standard deviation. Okay, so when you have the z, you identify is the z close to 1, close to 2, or close to 3. If your z is 1 or close to 1, then you can say that your observation, or about 68% of the observation, lies between two values. If your z is 2 or close to 2, you say that about 95% of the observations is between two values. And if your z is 3 or close to 3, you say that about 99.7% of the observations lie between two values. Okay, so I think that's where we kind of studied back in topic 2. So what we're going to do now is we are going to actually calculate what are those values. See, if you look at example 11, you are given this question where the mean of a probability distribution is 500 and the standard deviation is 10. So they ask you about 68% of the observation is between what values? About 95% of the observations is between what values? And virtually all is about 99.7%. is between what value. So if you notice, you're asked to find what are the two values. Okay, right, so we can actually use the empirical rule here. Now remember, okay, before you start, it's best to like sketch the information that you have. So here you basically have a normal distribution, and they told you that the mean is 500. Okay, sorry about this. Means, yeah, it's a bit difficult to be sketching on the monitor. Okay, so basically this is what we have. So they say about 68% lies between what value? So if you remember your empirical rule, you would know that 68% is 1 standard deviation, correct? So let's sketch that. So it should be around here. Okay, so this is like 1 standard deviation from the mean. Okay, so basically this is what we do there. So if you look at this formula, it's always starting from the mean. Okay, so it's the mean. Okay, I'm circling what you should look at here, this one. See, the mean plus minus 1 standard deviation. Why plus minus? Because you're looking at two sides here. See, you're looking at one side here and another side here. That's why it's plus and minus from the mean. Okay, so from our example here, we know the mean is 500, so plus minus 1 standard deviation. Why 1? Because you know it's 68%, so pay attention. Okay, so you just put it into the formula. You put a 1 here, you put a 10 here. It's 10 here because it's standard deviation, and 500 is the mean, so you get the answer, which is 490 and 510. So the next question, what about 95% of the observation lies between what value? So you just keep on writing 500 plus minus 2 now, because you know 95% is basically 2 standard deviations from the mean. So you keep on putting it inside put all of the values into the formula and you get the answer, 480 and 520. And finally, virtually all, or about 99.7% of the observations lie between what values? So it's basically 500 plus minus 3 standard deviation. So you'll get your answer, 470 and 530. You may have remembered from the very first slide of this virtual lecture, I mentioned that some normal distributions can have the same mean but different standard deviations, whereas some normal distributions can have the same standard deviations but different means. And sometimes the normal distributions can have different means and different standard deviations. What I'm trying to say is, for any normal distribution, it can take any values of mean and any values of standard deviation. So here we're going to learn a special type of normal distribution called the standard normal. Okay, so why is this standard normal special? Standard normal is special because it has a unique mean and a unique standard deviation. As you can read here, for the standard normal distribution, the mean is always 0 and the standard deviation is always 1. So you might be wondering, why do we need to learn the standard normal? Well, the answer is very simple. It is to help us calculate probabilities if our data or if our distribution follows the normal distribution. Okay. Now, if you recall, when we studied binomial and Poisson, there are two ways to find probabilities, right? The first way is to use the formula. The second way is to use the table. Now, to find probabilities for a normal distribution, although there is a formula that we can use, but generally in practice, we don't use the formula because it is very, very complicated. So how do we find probabilities for a normal distribution? It's by way of table. Okay, so that's the only way. Now, here's a look at the normal curve or the normal table. So if you look carefully at the values here, we have no z. What is only available is z. So what that means is you need to convert, or you need to change all of your x values into z first. Then only you can use the normal curve. Okay, so how can we do that? Is by using the standardizing formula. Okay, so this is called the standardizing formula. Now, if you look at the standardizing formula, it looks kind of familiar because you have seen it before. Where have you seen it before? Okay, remember the previous slides when we studied empirical rule? The first step to using empirical rule is to find z, right? Remember? Okay, how do we find z? It is distance over standard deviation. Now remember, what is distance? Distance is basically the difference or the distance between a particular x value from the mean. So isn't that the same thing as this numerator up here? X minus mu? Yes, it's the same thing. And down here, standard deviation is exactly the same here as the denominator, standard deviation. So in other words, this standardizing formula is nothing new. You've seen it before when we studied empirical rule and Chebyshev's theorem. Okay, all right, let me just erase everything because it looks a bit crowded. Okay, so let me repeat again. Before you can find probabilities using the table, the first step you need to do is to standardize. Standardize all of your x values to become z. And then only we can use the normal table, which looks like this. Okay, so I'll probably teach you how to read this table in the next slide. So for now, just focus on these two. Okay, now let's look at this example 12. So it's a exercise as to how can we find the z values. Okay, so if you notice for example 12, I have not yet asked you to find probabilities. It's just what is z, what is z. Okay, so it's just a quick practice as to how we can calculate the z value. Okay, so it says here, a recent national survey concluded that the typical person consumes 48 ounces of water every day. Now, assume daily water consumption follows a normal distribution with a standard deviation of 12.8 ounce. Okay, so A, what is the Z value for a person who consumes 64 ounces of water every day? How does this person compare to the national average? And B, what is the Z value for a person who consumes 32 ounces of water? And how does this person compare? Okay, first things first, you know that for this question, it follows the normal distribution. Now, you know that for every normal distribution, there's always two things. One is the mean, and you have the standard deviation, correct? So these are the two things. So they already told you from the question here, the mean is 48. How do you know the mean is 48? Because they tell you the typical customer, typical person, you know, typical is average, okay? Another way to say average is typical. So you know the mean is 48, and you also know the standard deviation is 12.8. So you've got these two important figures, okay? So basically you can input these numbers into the formula, correct? Okay, so now for A, what is the Z value for a person who consumes 64 ounces? So 64 here is your X. Okay, remember what is X? You need to define the variable first. X is basically what? Yeah, the amount of water. Okay, maybe I should be typing. Okay, I should just mention it again. Okay, what is X? X is the amount of water consumed by the average person. Okay, so that is your random variable. Remember, when you want to say what is the X, it is not a number, it is a statement. So in this question, X is the amount of water consumption. All right, so for part A, your X is 64. Okay, so this is what you do. X here, 64, minus the mean, which is 48. 48, divide by the standard deviation, which is 12.8. So you'll get 1.25. So that is the Z value for 64 ounces. So the next question is, how does this person compare? So you need to compare your answer here, 1.25, with the average. What's the average just now? The average is, yeah, 48 ounces. Now, I mentioned to you just now, remember here where we talked about standard normal, it's special because the mean is always 0. What that means is whenever you're given an average, if you were to standardize that average, it will always be 0. Why? Because the mean is 48 and the X value is also 48. So 48 minus 48 is 0. Over standard deviation, you get 0. So in this case, in other words, you need to compare 1.25 with 0. Okay, so how do you compare? The person consumes more than the national average. Why more? Because 1.25 is more than 0. Very simple. Okay, now let's look at the next question. B, what is the Z value for a person who consumes 32 ounces? Now your X is 32. So if you were to write it down, see, 32 minus 48 over 12.8. Okay, so your X is 32 minus the mean, 48, over the standard deviation, 12.8. You will get negative or minus 1.25. Okay, so compare minus 1.25 with 0. Is it more or less than 0? Yes, it's less than 0. Therefore, to interpret, we say the person consumes less than the national average. Now let's learn on how to find probabilities for any normal distribution. First things first, before you want to find the probabilities, you need to convert your normal distribution to become the standard normal. Okay, so what that means is you need to convert all of your x values to become z. How? By using the standardizing formula, which is x minus mu over standard deviation. Okay, you can just refer to the previous slides. Right. So now, after you convert your x values into z, we can actually use the normal curve or normal table to find the probabilities. Now, there are generally 4 ways to find probabilities using the normal table. Okay, so okay, before I show you the normal table, I would like to just remind you again. Okay, so here is your normal distribution. In the center here would be your mean, right? Okay, so please take note, this particular line is your x values. Okay, it basically whatever number along this line, it is any x values. Okay, it could be anything, and in the center is obviously your mean. Okay, now whenever we convert any of these x values, it will become z. So I need you to imagine there's a parallel line down here, which is like the same distance with your x, but we call it the z values. Okay, so whenever we standardize the mean, you will get 0. Okay, it's always like that. Okay, so for a particular x, let's say this value is x1. If you standardize x1, you will get z1. Let's say this is another value, x2. Okay, you will get a z2. Understand? So whenever you have an x, it will have a corresponding z value under it. Okay, now when you use the z table, obviously this z does not, this x does not exist. You will only be focusing on the z. Okay, I need you to understand that. All right, so if you understood, so I'm just going to erase this so that I can show you the z table. Okay, hold on a minute. It's taking a lot longer than I thought. Okay, all right, so here is your z table. Okay, let's look at the first case. The first case here is they ask you to find the probability between the mean and a selected x. Now remember, for every x, when you convert it, you'll get a z. Okay, so basically now what you have is basically this diagram. For a particular area, or probability is basically the area under the curve. Okay, so if you want to find the probability between the mean and a selected z, you're actually looking, here's the mean, which is 0, and a selected z value, which is 1.96. So what is the probability? How do you get that 0.4750? Is by looking directly at the table. Very simple. So let's look at 1.9, which is here, 1.9, and then look at 6, 1.96. So here it is. This is 0.475, which is your probability. So that's your answer. Very straightforward. Okay, so this is basically case number 1. Now let's look at case number 2. Okay, I shall use another colored pen. For case number 2, they ask you to find the probability beyond. Okay, let me just erase this. You need to find the probability beyond a particular z value. Okay, so let's sketch this line. Okay, remember just now you have, okay, this is x bar. But now instead of finding this probability, we don't want this probability. We want this probability beyond a particular z value. Okay, it could be here. So you want this area. Okay, so how to find this probability or this area? It's very simple. Let's say, okay, down here is 0. Okay, just like the cases now. Let's see, here's 0. And let's say the figure here is 1.96. So basically, if you notice, I'm drawing exactly this. Okay, here. But instead of wanting to know what is the probability between the mean to 1.96, I want to know this one, beyond 1.96. So how do we find that? Very simple. Okay, if you notice, recall, one of the characteristics of probability is that total probability is 100%, right? 100% is 1. So if you were to divide 1 into 2 or half, you'll get that half of this is 0.5. Okay, so we already know this area just now, right? This area was 0.475 here from this first example. So this is 0.475. So if you want this blue area, what do? Simple. Okay, 0.5 you minus 0.475. So you will get the blue area. Okay, so in other words, let's go back here, how to find probabilities beyond a particular x or z value. We locate the probability of z first. Yeah, that's what we did. We find the z first, which is 1.96, and then you subtract that probability from half. See, 1.96 is the z, 0.475 is the probability. So we subtract the probability from half. Then you will get the area beyond that particular value. Okay, all right, so I'm going to erase all of this. No, don't worry guys, if you don't understand what I'm talking about, you can just repeat the video and of course read the textbook for further clarification. Now let's look at case 3. For case 3, you need to find the probability between 2 points on different sides of the mean. Okay, let's sketch. Okay, let's see here we have the probability normal. So here's your x bar. So let's see, we've got 2x. Here's x1 and here is x2. Now you want this area. See, do you understand what I'm drawing here? I'm actually drawing case 3 to find the probability between 2 points on different sides of the mean. Remember, x bar is your mean. x1 is to the right of the mean. x2 is to the left of the mean. So you've got two values of x which are on different sides of the mean. So what you need to do first is, number 1, find the z value for all of it. So here, okay, to find the z value, and you know, whenever we standardize the mean, you get 0. You standardize x bar 1, you get z1. You standardize x2, you get z2. So you look at the table, what is z1? So you will know this probability. You look at the table for z2, you will know this probability. Now to get the red area combined, you just add this probability, you add with the other probability. So this is what it means, okay? Determine the z values and then you add the corresponding probabilities. Okay, now let's erase this. Let's do for the last case, which is case number 4. Case number 4 is if you're asked to find the probabilities between 2 points, but this time the points are on the same sides of the mean. Okay, let's draw. Okay, this is your normal distribution. Again, here's your x bar or the mean. Let's say you've got 2 points. This is x1, this is x2. Remember, how is this different from just now? Just now, x1 and x2 are on different sides of the mean, one to the left, one to the right. But now both are on the same side. Okay, so what you need to do first is find the z value for x1. So meaning it's from here to here. Okay, so if you were to find the z, you'll get here 0 and here is z1. And then secondly, you need to find the z value for x2, which is from the mean until x2. Okay, so you will get z2. Remember, whenever you read the table, okay, this table, it always starts from the mean. Okay, so as you can see here, you've got two areas. One is the blue area. The other one is the green area, but the green area includes the blue area, right? So if you want to find the difference between them, so what do? Yes, you take the larger probability, which is the green, you subtract the smaller probability, which is the blue. Then you will get only this area. Hold on, you will get this area. Okay, I know you need to do more practice, then you can get it. Okay, so anyway, hopefully by my explanation you'll be able to get a bit or the gist of everything. Okay, so I'm going to erase everything here. Now you can try and do example 13 and see if you understand what was being mentioned. Okay, let's look at example 13. For A, okay, we have this question. General Hospital's patient account division has compiled data on the age of accounts receivables. the data collected indicate that the age of the accounts follow a normal distribution with a mean 28 days and standard deviation of 8. Okay, so you are given the two most important information for any normal distribution, which is the mean and the standard deviation. Okay, so maybe you can start by sketching. Okay, so you have a normal distribution. The mean is 28. Okay, let me just do my 8 properly. 28, okay, 28, and the standard deviation is 8. Okay, you can't really sketch the standard deviation, so you just have to put it aside. Okay, remember, all of these values on this line refers to your x values. Okay, so now they ask you, what is the probability that the accounts are between 20 and 40? Between 20 and 40. So 20 is to the left of 28, right? So it's somewhere here. 40 is to the left of 28. So let's see, it's somewhere here. Okay, so if you notice, which case is this? Is this case 1, case 2, case 3, or 4? Yes, it's case 4. Sorry, case 3. Okay, case 3, because you are asked to find the probability between 2 points on different sides of the mean. So to sketch is you want this area. You want this area. Okay. All right. So let me just erase it because I do have some working that I need you to see. Okay, so now let's look at question A. This is how we write it. Okay, you want to find the probability that the account is between 20 and 80 and 20 and 40. Remember, you need to define your random variable first. So in this case, our x is what? What is our x? Is the count. Okay, the number of days. The account is between what days? So in the first step you need to do is to standardize 20 and 40 to make them become z. So how do you do that? We apply the standardizing formula. X, which is 20, minus the mean, which is 28, over standard deviation 8. Here, remember, 40 is also z. X. You've got two x here, 20 and 40. So you need to convert both 20 and 40 to become z. So once you've converted it, you get minus 1 and 1.5. Now remember, whenever you standardize, the x automatically becomes z. You notice that? Here, the question is you still write it as x, but the moment you standardize, it becomes z. Okay? All right. So now, you know the two values. 20 becomes minus 1. 40 becomes minus 1.5. So you can actually sketch it. If I were you, I would sketch. So here, okay, basically you have 0. Okay, 1 is negative 1. Why is it negative 1 to the left? Because it's, negative is less than 0. Another one is 1.5. So we want this area, okay? So next step here. So how do you get this? Okay, look at the table. 1. What is 1? 1 is here. 1 is basically 1.0. 1.0, if you look at the table, it's 0.3413. That's how we get 0.3413. Now look at 1.5. Look at 1.5, it's here. 1.5 is here. 1.5 is basically 0.4332. That's how you get 0.4332. And you remember case number 3, we find the z value separately, and then we find the corresponding probability for each z value, and then we add them together. So your answer is 0.7745. Okay. Now for the second question, what is the probability that the accounts are less than 30? Now, less than 30, which case is it? Is it case number 1, 2, 3, or 4? Less than. Less than is a beyond question. Okay, so we're looking at case number 2. Okay, so how do you do that? The first thing you need to do is to write down the question. Here, they ask you to find the probability that the accounts are less than 30 days. Now, next step is to standardize 30. How do you standardize 30? 30 minus 28 over 8. So you'll get 0.25. Now, look at 0.25. 0.25 is basically 0.0987. Here, 0.25. Okay, let me just circle that for you here. 0.25, 0.0987. Okay, but remember, that's not your answer. You need to plus with 0.5. How? Okay, I think it's very important for you to sketch, okay, because if you don't sketch, you won't be able to see how it looks like. Remember, here's your diagram, here's half, the mean is 0, and then remember the mean is 28, okay, so 30 is here, okay, so 30, when you standardize, you get 0.25 here, all right, so you want the area less than 30, so meaning this is the area that you want. See, it's very, very important for you to sketch. Only from here you'll know that you need to add with half. Why? Because here, this whole area is half. This area is 0.0987. So to get the area, you need to add them together. So your answer is 0.5987. Okay? Let's try example 14. A building contractor claims he can renovate a 200 square feet kitchen and dining room in 40 work hours, plus or minus 5 hours. The work includes the following. Assume from past experience that times to complete similar projects are normally distributed. Okay, so they already tell you that this distribution follows the normal distribution with mean and standard deviation as estimated above. In other words, 40 hours is the mean, 5 hours is the standard deviation. Okay, so for question 1, what is the likelihood? Okay, likelihood is another way to say probability. What is the likelihood the project will be completed in less than 35 hours? Okay, first things first, you need to define your random variable. Your random variable here is x. X is basically what? X is the time taken to complete the project. Okay, so that is x. Remember, random variable is a statement. X in this question is the amount of time or the time taken to complete the project. So A, how do you write that first? Yeah, probability that X is less than 35. This is the first step. Second step is you need to standardize 35. Standardize 35 to convert it into Z. What do you need to do? 35 minus the mean, which is 40, divide by standard deviation, which is 5. Here. So you'll get a minus 1. Okay. So here you need to sketch. Okay, remember again, the first step was to write down the question. Second step is to standardize. Third step is to sketch. You need to sketch. Then only you'll know whether to plus half, minus from half, or add together, or minus from each other. Okay. So I hope you understand what I'm drawing here. You want this area less than 35. Okay, so how to get that? First of all, you need to know what is the probability for minus 1. To find the probability for minus 1, all you need to do is look at the table directly, and you'll be able to see that for the probability of 1, okay, remember the negative sign here just tells you the direction, okay, whether you're going to the left or right. If you look at the Z table, there's no negative, okay, you can ignore the negative sign whenever you look for probabilities because it doesn't exist. So in other words, this negative sign just tells you that we're looking to the left of the table. Okay, right. So from the table, if you look at 1, you get 0.3413. So therefore, to get the probability beyond 35, you need to deduct 0.3413 from half. So your answer is 0.1587. Okay, remember this 0.1587 is this striped area. Okay, right. Now for the next question that I want to try with you is C. What is the likelihood or probability that the project will be completed between 43 and 48 hours? First things first, write on the question. Second step is to standardize both 43 and 48. There you go. Okay, remember how to standardize? You take that x value, you minus the mean, divide by the standard deviation. So you get 0.6 and 1.6 respectively. Next step is to sketch. There. As you can see, both 43 and 48, they fall on the same side of the mean, right? So it's basically case number 3. Was it 4? Yeah, one of the cases found mistaken. So you check again whether it's case number 3 or 4. Sorry, same side of the mean is case number 4. Okay, so find the probability for 0.6. The probability for 0.6 is 0.2257 here. The probability for 1.6 is 0.5 4452. So how to get the striped area? You just deduct the smaller probability from the bigger probability. So you get the answer. The striped area is 0.2195. Finally, let's try D. What is the likelihood that the project will be completed between 38 and 45 hours? Step number 1, write down the question. Step number 2 is to standardize 38 and 45. So it will give you negative 0.4 and 1. Step number 3 is to sketch. Now, as you can see here, can you compare how it's different from question C just now? For C here, both the Z values are on the same side of the mean. For this question D here, okay, the Z values are on different sides of the mean. Remember, if it's different sides of the mean, you need to add the corresponding probabilities. Okay, so what you need to do is here, you just add them. 0.1554 plus 0.3413, you'll get your answer, which is 0.4967. Now this 0.4967 corresponds to the striped area. Now please do B and E yourself. Here I shall give you the answers. Okay, you go and try yourself. Let's look at example 15, which is the last example in this virtual lecture. Among US cities with a population of more than 250,000, the mean one-way commute to work is 24.3 minutes. The longest one-way travel time is New York City, where the mean time is 38.3 minutes. Assume the distribution of travel times in New York City follows the normal distribution and the standard deviation is 7.5 minutes. Okay, if you noticed, there are two means here. You need to determine which one is more relevant. So in order to know which mean is relevant, you need to define your x. In this case, x, or your random variable, is the commute time in New York City. Okay, so what is the mean related to New York? Yes, it is 38.3. So your 38.3 is the mean. 7.5 is the standard deviation. So these are the important information that you need to know. Let's look at question A. What percent of the New York City commutes are less than 30 minutes? So let's write the question first. Less than 30. Next step is to standardize 30. So 30 minus the mean, which is 38.3, over standard deviation. Okay. Now you get the Z, which is negative 1.11. Okay, the next thing you need to do is to sketch the area. So you know that you want to sketch area below 30. In other words, below negative 1.11. So how do you do that? You find the probability of 1.11 first. So the probability of 1.11 is 0.3665. Please look at the table, okay? Whenever we do this, you need to refer to the table because you need to know how to read the table. Okay, but you want this striped area. So how to get the striped area? You just deduct 0.3665 from half. So you'll get 0.1335. But since the question asked you what percent, you need to multiply with 100. So your answer is 13.4%. Okay. Now for question C, what percent are between 30 and 40 minutes? So write in the question. Okay, so next step is to standardize 30 and 40 respectively. You'll get these figures. Okay, next you need to sketch the diagram. Okay, so in this case, you want to find the probabilities between 2 points on different sides of the mean. Okay, so 2 points on different sides of the mean. In other words, you're looking at case number 3. Okay, so what you need to do is find the probabilities that corresponds to the Z value. So 1.11, the probability is 0.3605. 0.23, the probability is 0.0910. So to get this area, you need to just add the two probabilities together. So your answer is 0.4575, or in percentage, it's 45.8%. Okay, so before I end, allow me to remind you again, these values in blue are Z. Okay, the values in red are probabilities. Again, these values are Z. Z's are not probabilities. Z is just the distance of the X value that you convert into Z from the mean. Okay? Okay, so that wraps up this virtual lecture. Please try out the remaining exercises. Okay, I've already given you the answers. Just try to work on the workings and check your answers. Okay.